Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Muhammad Ayub. I will present about the case study of industrial building system method in HKL, which is a hospital Kuala Lumpur. First of all, the introduction. The industry is required to employ the IBIS system for construction project. According to Harun, as indicated by their expanding global market, the experience of certain industrial countries such as Japan, Germany, and the United Kingdom show the IBS has a lot of room for the improvement. In addition to reducing resource waste, the IBS construction process may provide consumers with high quality result. In Malaysia, the use of IBS as a construction approach is evolving. International firms also play a significant part in our effort to transform Malaysia into a more technologically advanced country, which is quickly becoming a benchmark and reference. Based on the case study, we had discussed with our group members to select the appropriate location to make a case study. The selected case study is the Kuala Lumpur Hospital, commonly known as a HKL Hospital Kuala Lumpur. HKL is a not-for-profit organization that serves as the flagship hospital in Malaysia's public healthcare system. It was founded in 1870. Hospital Kuala Lumpur is presently Malaysia's largest hospital and one of the largest in Asia, according to the Malaysian Ministry of Health. In 2013, the structure houses have been improved to 16 clinical departments, as well as support service like pharmacology, pathology, radiology, and the central sterile supply units, which is a CSSU, and the allied health. Okay, for the literature review, IBS is a building approach that involves creating pieces in a controlled setting on or off-site, then transporting, positioning, and assembling them into a project with a limited on-site involvement. To be honest, the construction work on a project will flow easily if the IBS approach is used because it is applicable and relevant in our period. According to research published by the Malaysian Ministry for Local Government and Housing, the key advantages of utilizing IBS are speed of construction, quality, and the cost savings. The construction methods can be divided into 4 categories, which is the conventional, cast in situ, composite, and the fully prefabricated, and also there have been 5 main types of industrialized building system, which is the IBS, is a precast concrete system, framing steel system, formwork steel system, blockwork system, and prefabricated timber framing system.
Okay, my name is Muhammad Azmi. I will explain the purpose of industrial building system of SACC HKL, which is precast component, in situ column, dry wall system, and lightweight block. So, precast component is a product that is manufactured by casting concrete in reusable mold or form, which is then allowed to cure in a controlled setting. It is carried to building site where it is hoisted and placed into position. Precast beam. Precast beam used for suspended flooring, used as ledge for other form of precast flooring to sit on. So there are 5 types: T-beam, L-beam, rectangular beam, U-beam, and beam shell. It can be either reinforced with either pre-stressed strand or conventional reinforcing bar, and it will depend on the spans, loading, and the precast production method. Precast Holocaust Lab. A simply supported slab of a pre-stressed concrete member with tensile pre-stressing without web reinforcement. It offers the ideal structural section by reducing the weight and providing the maximum structural efficiency within the slab depth. It is practical as it has a lower weight and it has span length, thinner depth, easier installation, fire resistant and high sound resistant. Precast staircase. The staircase is structural member that provide access from one floor to another floor. The precast staircase is made up of reinforced concrete to eliminate the trouble of adjusting the number of steps, riser, sun and width of stair flight. It is more precise in measurement that can fit in the structural system. It is more strength and low maintenance cost. In addition, it is also saving more cost, save time and space on site, and reduce the wastage of formwork during the construction period. Drywall system. It is a series of lightweight walls that are assembled with aluminum zinc alloy, coat steel component together with one or more layers of gypsum board fixed to one or both sides of the wall, as well as insulation material. Drywall is also highly vulnerable to moisture due to the inherent properties of the material that comprise gypsum, paper and organic additive blending. The plaster is mixed with fiber, plasticizer, forming agent and various additives that can reduce mildew, flammability and water absorption. Lightweight block. It is made of expand aggregates such as shale, clay or slate to reduce the density and wear compared to the standard concrete block. It is flexible and easily transportable building material. Require a little support from materials such as steel or additional concrete. It is cost effective, low thermal conductivity and fire resistant.
Hi, I'm Maizatu Zuliana. I will be presenting the IBS features. The first IBS component that has been used in the case study is precast beam. The suitability. The use of this precast building is highly demanded by buildings that provide public service such as hospitals in order to maintain the integrity of the building to prevent any adverse events such as earthquake. The fabrication. First, mold used for such application must be extremely durable, which is why steel molds are so popular today. Clean and debris-free mold is required. Second, putting the beam reinforcement in place. Steel bars, cast throughout, corrugated sleeve pipe, recesses, lifting hooks, plus insert all need to be properly fitted and secure. Third, verify that the concrete grade utilized meet the design standards. Fourth, assure have enough curing time and the ideal environment. Loosen and remove the bolts and pin from the mold case and take out the component from mold before lifting. Next is connection detail. The bearing pads on the column cobles are used to secure the precast beam. The pad accept expansion, contraction and rotation at the bearing region, protecting the supporting concrete components from swelling and cracking. Steel angles are connected to metal plates, form into the beams and columns, and the connection is grouted solid. Last is installation process. First, beam is raised off the ground using a suitable lifting chain with the appropriate lifting capacity and length. Second, after the component has been raised to the correct height, it should be turned into the precise holes above the column bolts. The installer who is standing at the installation location should carefully lower the component and modify it to ensure that it fits properly. Third, after being inserted, the connection between two components must be welded. The welding process is essential for the assembly of each component. Fourth, once the components are ready to be placed, the grout mixture should be ready. To ensure that the components will fit together correctly, gaps or joints must be filled with grout mixed cement. For this case study, autoclave aerated concrete AAC or a lightweight block wall system were employed. For the suitability, AAC is utilized as infill walls all over the world. It is generally known that infill wall seismic performance in previous earthquakes was inadequate for both economic and psychological reasons. For the fabrication, first, prepare all the materials such as cement with 53 grade ordinary Portland cement, fly ash or sand, limestone powder and gypsum. Second, a container is filled with fly ash. Pumping is turned off once the desired weight has been pumped in. Conveyors are used to distribute lime powder, cement and gypsum into individual containers. The dosing unit disperses the mixture into the molds in predetermined amounts. Third, once the raw material mixture is complete, it is put into mold. Aluminium interacts with calcium hydroxide and water and emits hydrogen gas when the slurry is blended and put into the grease mold. Fourth, once the block has reached chopping strength, it may be demolded and cut into the desired size. Next, for the connection detail, infill wall system link directly to precast column and slab utilizing sand cement mortar, glute joint mortar, bed joint reinforcement, and head joint for the case study. To join the blocks together, sand cement mortar will be utilized throughout the wall. As increase the wall structure strength, glute mortar is employed. The flat truss bed joint is masonry reinforcement and enhance the structural reinforcement of masonry wall by adding resistance to lateral stress like wind. For the installation process for the lightweight block, first, using a masonry trowel, create a full width 1/2 deep sand cement mortar joint at the uppermost corner of the slab. Second, place the first corner block in the sand cement mortar and make any necessary adjustment to the junction. Lower or elevate the block to the desired height by tapping it down with a rubber mallet or by putting more mortar beneath it. Third, glute joint mortar will be used to bind the block to the precast column, beam and slab. Fourth, in a clean mixing container, combine authorized thin bed mortar and water. The thin bed mortar should have a consistency that allows it to flow freely between the teeth of the notched trowel, leaving the teeth formed in the mortar bed. Fifth, using the 15-inch notch trowel, apply thin bed mortar to the head joint of the second corner block. To finish the leveling course, put a thread between the corners after you have built the lead corners. For the bed joint, sand cement mortar should be used, and for each head joint, thin bed mortar should be utilized to ensure a plumb wall level across each block. And last is glute mortar was used to install the flat truss bed joint reinforcement to guarantee its stay in place. The last IBS component is precast staircase. For the suitability, a hospital is a location where patients are treated, all of which are necessary to guarantee that the building's construction is sturdy and long-lasting. The emergency staircase will be the primary means to exiting the building. This guarantees that people may utilize the building in a safe and risk-free manner. For the fabrication, there are two processes, which is casting and finishing. For the casting, the thread or riser portion is open Z and half Z stairs components. The casting process must be incorporate all attachment, reinforcing steel, and handling devices required for proper installation and handling of units. For the finishing, produce smooth, accurate, and form-finished components that are within required casting tolerance. For the connection detail for the precast staircase, the landing slab lies atop a rolled steel angle (RSA) that is fastened to the wall for the essential landing-to-wall connection. Between the RSA and the landing slab, a structural shim packer is used to level the landing slab before commitment. Furthermore, the stairs-to-slab connection necessitate the use of a structural shim packer and rests on the ledge casted into the floor slab. A hole is drilled through the stair step, the shim packer, and it comes to halt when it reaches the slab. The hole is filled with grout and a metal dowel piece is inserted. The installation process for the precast staircase: first, when the precast steps arrive on the site, They will be suspended from the chain linked to the lifting machine using a hook that was pinned to the staircase during the production process. Second, steel brackets are used to hold the precast stair landing to the wall and beam. A bolt are used to fix it. To guarantee that the staircase is stable, it is fastened to the precast concrete slab with a dowel bar through the dowel holes. Third, grout open areas are at connection and join between platforms and staircase, as well as between platforms and floor planks. One precast component have been set and fastened. Grout should be applied in such a way that is smooth, plumb and level with the neighboring concrete surface.
Hi, I'm Iza. I will be presenting Precast Holocaust Labs, which is the fourth IBS component feature. Slabs with a hollow core are pre-stressed concrete components with a constant cross-section. For the suitability of this hollow core slab, this slab is lighter than a massive solid concrete floor slab. This slab is lowering the structural weight of the building. With higher quality, these slabs are able to minimize the number of prop needed during construction works and have quicker installation procedure. For fabrication, first prepare the slab casting bed. Prior to casting, clean and oil the bed. Tensioning all strands for a single bed may be done concurrently or individually over the reinforcing when concrete. After drying, the slab is trimmed to size. After slicing the slab, it is withdrawn from the casting, moving the slab to an automatic drilling machine for drainage holes at both ends. Finally, the slabs are graded. Moving on to the connection details. This slab has two kinds of connection, which is slab to beam and slab to slab. For slab to beam, precast beam bearing pad supports hollow core slab with steel reinforcing bar inserted into slab keyways. It may be left unfinished or tapped with concrete. For slab-to-slab connection, side-cast concrete fill and reinforcing steel are employed. The side-cast concrete topping is put to the connecting fill. Moving on to installation process. Firstly is to prepare for the installation of hollow core slab. Next, inspect and support the hollow core slab. Verify each slab with the plan. Examine the lifting groove and the clamps projecting lip. Do not lift a damaged slab. Thirdly is lifting process. Clamp its projecting lip into the slab's groove. Tighten and lock the safety chain below 100 meter with a spreader beam and lifting clamps. Keep radio contact with the crane operator and follow the manufacturer's lifting point suggestion. It must be less than 60 degrees apart. Fourth, installing the slab. If needed, a rope may be tied to the slab. Remove the safety chain when the slab is 100 mm or less above the support. Use an installation bar to set the slab. To level slab chamber differences, use supports, adjustment bolts, and shims as needed. Build the rails right quickly. Lastly is joint grouting and follow-up. The prefabricated steel roof truss is the final IBS component for this construction. A roof truss is made up of equal parts tensile and compression forces to operate as a single item bearing a load across a span. For the suitability, prefabricated steel trusses provide high strength and lightweight roof system. Steel roof trusses last longer and need less maintenance in terms of termite resistance, while steel profiles assist decreased structural stress. For fabrication of prefabricated steel roof truss, the first step is cutting. Steel trusses may be cut by plasma, laser or water jet, and holes are pierced using high pressure notches. Secondly is forming. Trusses also made via press baking and rolling. And the last step in the assembly process, which involves joining all of the individual components to form. For the connection details, truss members are joined together by welds or bolts at the joints. Joints are constructed as pins, and the forces in truss member are fully balanced at the joints. Along the whole span, the top and bottom cords are evenly parallel to each other. Each cord is attached to the column independently through a simple pin connection. Moving on to the installation procedure. First, calibrated survey equipment will be used to align and survey. Next, the anchor bolts for the steel framework will be fitted. These are either cast into RCC walls, slabs, Columns are chemically cemented in place. Existing structural holes will be bored using a concrete bit. Drill to the manufacturer's depth. Pull-out test and drilling reference to drilling materials should be specified. Then, erect the columns using suitable lifting devices and double-check their verticality. Provide shim plates as needed. Begins building connection beams after completing all frames column and bolting them. Only a single frame with all connection beams can completely tighten the bolts. On-site sheet repair will be done when the construction is finished. Purlin plate connectors will fasten Z purlins to roof beams. Next, install roof sandwich panel over Z purlins with sheeting screws. The appropriate flashings and gutters will be supplied, and lastly, cleaning and touch-up work will be conducted after construction and roofing.
There are 5 main components of using IBS system for this case study. They are walls, beam, column, slab, and staircase. The following shows the process of installing the IBS components at the construction site. There will be start with the setting out and foundation trenches. Procedure of laying down the excavation lines and center lines on the ground before excavation begins. Then, strip foundation is laid out as referring to the layout. Next, the ground beam. The beams are used as horizontal and connections between the footings and be reinforced with continuous reinforcement developed within or beyond the supported column. Then we'll be continue with the slab installation. The slabs will be lifted by choosing of a lifting mechanism that is appropriate for the conditions on the job site, as well as the way of the hollow core slabs need to be done. A spreader beam and lifting clamps will be used to install the hollow core slabs. Column. Procedure will proceed with a start installing of the formwork, and concrete is placed in the desired spot or into a dumper or pump via a chute that extends from the back of the vehicle. This procedure necessitates a strength test and curing time, making it more time-consuming to produce than precast concrete. The sizes of precast components are too large to lift, so casting in situ is the best option. Then we'll continue with the placing units for the block wall. The first stage in laying out the wall is to take measurement from the foundation or floor plan and then transfer those measures to the foundation, footing, or floor slab. The chalk line or any alternative material is drawn on the foundation surface to establish the line to which the block's face will be put once 2 points of measurement have been established, corner to corner. A final check of all measurements should be conducted once the entire surface has been marked for the location of walls, apertures, and control joints. Starting with the corners, the lightweight block lays the first course without mortar so that the dimension on the floor of foundation plan can be seen checked against how the first course meets the plan. The concrete block will be installed throughout the entire width and length of the foundation, floor slab, and even across openings during this dry layout. Lintels for door and window opening. When building with concrete block wall, a lintel must be installed before the load-bearing wall may be opened. A lintel transfers the load of a wall away from the material beneath it and into the foundation of a building, it allowing new openings in the wall to be built without causing serious damage to the entire structure system. First, floor slab. For this case study, it used the hollow core slab, which then be mounted in the beam, and the reinforced bar are blended into the hollow core slab to ensure that the slabs are securely fixed. The same process is repeated subsequently for each floor. And the last process is the staircase. The building's precast concrete staircase is lifted and fitted. The stairwell's perimeter should be safeguarded before the stairs are installed via scaffold handrails. This will prevent occupants falls into the stairs during and after the surrounding floor units are installed. The construction will be very quick because the components will be made ahead of the time.
Moving forward to the IBIS score calculation for the building. So what is actually an IBIS score? So IBIS score is an organized evaluation system used to quantify the use of IBS in a consistent manner. The higher IBS scores imply higher productivity, less site labor, smaller wastage, less site materials, cleaner environment, better quality, neater and safer building sites, and cheaper total construction costs. So how do we calculate the IBS score for a specific building? We can calculate using those IBS score formula. There are three components to calculate the maximum IBS score for a building. So for our selected case study, Hospital Kuala Lumpur HKL Block A1, the first component is structural system with the maximum score of 50 points. So using the formula below, where QS over QST is the percentage of the construction area of which a particular structure system is used. Meanwhile, Fs is the IBS factor for the particular structural system. So structural system, for example, is precast concrete beams, column, steel, and also prefabricated timber. The second component is wall system with the maximum score of 30 points. So the formula is quite different than the structural system, where QW over QWT is the ratio of the length of a particular wall system, external or internal, used out of a total wall length of the building. Meanwhile, FW is the IBS factor for the particular wall system. So the last component is other simplified construction solutions with the maximum score of 20 points. So points are given based on the percentage of coverage of a particular solution and sum up to form the IBS score for this section. No points are given if the coverage is less than 50%. So if we total up the structural system, the wall system, and other simplified construction solutions, we obtain the amount of 70.2 over 100, which has reached the target of IBS score calculation for this particular building.